First of all, let's talk about the first derivative. We know the derivative is the gradient of a tangent line. For y equals f of x, if you want to figure out at x equals to a, what's the slope of a tangent line, you need to figure out the y prime, f prime of x. Then you can plug a into this derivative function so that you can get the slope of a tangent line. For second one, when derivative equal to 0, you will find the stationary points. Stationary points means 3 points: local maximum, local minimum, then the stationary inflection point. Sometimes we use the word relative maximum or relative minimum. Compared to the word local, it will be global. Compared to relative, it will be absolute. So sometimes we talk about local relative minimum or maximum. We use the word global maximum or absolute maximum or minimum. So what's the difference between local and a global? For example, we call this is a local minimum. I use L stand for that. It's a local minimum. This one is we call this is a local maximum. Here, this one is a local minimum. When you're talking about the local, it has to be the turning point. The turning point. Sometimes your local maximum or local minimum will be the absolute. For example, look at the whole graph. We know this one, the local one, is also the global one. It's a global minimum. But look at the whole graph where you can find the global maximum or absolute maximum. It's here. This is the one we call this is a global maximum point. So basically, global or absolute maximum or minimum means the very highest point of your graph, or the very lowest point for your graph. We call this is a global or absolute maximum or minimum. The local or relative maximum or minimum will be the turning point, like this is a local minimum, local maximum. This is a local minimum. From this graph, we could find the points where the derivative of f of x equals to 0 at local minimum, that is x equals -3. For this one, it's x equals -2. Here, local minimum is x equals to 1. And also this one, 4, is a stationary inflection point. So from the graph, you could figure out where the derivative equal to 0. The third one, the relative can decide increasing or decreasing function in certain interval. When the derivative is positive, the function is increasing. When derivative is negative, the function is decreasing. So we use positive or negative to describe this derivative. Positive or negative or 0. But for the function, we will say the function is increasing or decreasing. When you see the derivative is increasing, which means the second derivative is positive. So remember, for the SL level, we use the positive, negative, or 0 to describe the derivative. Don't be confused with that. For example, for this graph, we can figure out where your derivative is positive. You just need to find the increasing function. So from here to here, it's increasing. From here to here, this is increasing. Then from here to here, increasing. Remember at 4 that your derivative equal to 0. See, for the local maximum and a local minimum, that's your derivative equal to 0. Therefore, we can write down the interval where the derivative is positive. It will be from -3 to -2. You see here. And this is the 1 to this 4. Union set is 1 to this 4. Then union set from 4, we go to here is 5. You can write down the inequality form, but we prefer interval form for advanced math. For the derivative less than 0, it will be from here to here, and from here to here. That's the decreasing function. Now we write down the interval from this point. We estimate it will be -3.8 to -3. Union set for this one is -2 to 1. -2 to 1. Now let's talk about when the derivative greater than 0. What kind of graph you will find? We call this is a quadratic pattern increasing. Then you have a linear pattern increasing or exponential pattern increasing like this. For the derivative less than 0, we know that it's a quadratic pattern decreasing and then it's linear decreasing, or it will be the exponential decay. Let's draw a conclusion about the relationship between derivative and the graph. When derivative of f of x less than 0, we know graph is decreasing. When the derivative of fx is positive, greater than 0, we know the graph is increasing. What's the meaning for derivative of fx equal to 0, which means the graph is not increasing, not decreasing, or at that point, it's not increasing, not decreasing. Therefore, what kind of graph is not increasing, not decreasing? We know that's horizontal line. For y equals a, it's not increasing, not decreasing. And also it's where you have a local maximum point, or you have a local minimum point. Or when you have we call that it's a stationary inflection point. Like this point. Or the graph something like this point. We call this is a stationary inflection point. For this decreasing graph, we know very beginning we learn like a linear pattern decreasing, linear function. Then later on we learn it's a quadratic pattern decreasing. Then we learn it's an exponential decay like this. For the increasing graph, we know linear pattern. then you could see here's the one is a quadratic pattern increasing, or it's an exponential pattern increasing. That's we call this is an exponential growth.